Good morning. I'd like to welcome you to our webinar this morning. We're going to be talking about protecting automated systems in harsh environments.
Rick, you need to move the slides.
We'd like to welcome you. We're in Los Angeles, California this morning. My name is Rick Dabb, Vice President of Falcon Electric, and I'll be your moderator this morning as we go through the Protecting Automated Systems in Harsh Environments. A couple of logistics before we begin. Our presentation is going to be about 60 minutes. It's divided into 3 different sessions that we will have question and answers available during it. I'll try to get those answered as we go through this. As a participant, we've asked you all to be listen-only mode as we have a great deal of people signed up today. You can ask your questions through the chat tool, and we'll answer those as we go ahead. To do that, you enter your questions into the chat tool in the WebEx window. We have 260 scheduled people today, so we can't open up all the phones, so we will get your questions answered. And if we miss a question, or if you'd like to discuss a topic in further detail, the 2 presenters' emails are listed at the end. With that, I'd like to introduce to you, first of all, Mr. Larry Thompson. Larry, would you like to say good morning for us?
Well, good morning, everyone. Actually, it's good afternoon where I'm at, but that's okay.
And then I'd also like to introduce from Falcon Electric, Mr. Michael Stow.
Good morning to everybody.
These gentlemen, along with myself, I added it up this morning, about 71 years of UPS experience. So we look forward to the opportunity to talk. Larry, could you tell us a little bit about what we would plan on learning today?
Well, you'll learn why you need, all UPS, all SCADA and most industrial equipment needs a UPS. You will also learn that most UPSs that are sold, even in the industrial area, are those designed for an office environment. Your choice of a standby power system or a true UPS addresses a number of power problems and power anomalies. We'll go into these in some later slides, but the only one that offers true, or I would say a high degree of protection, will be a true UPS or a true online UPS. And the online PS will be one that is built with components designed to cover a wide range of temperatures and the environmental conditions that you will find your applications in. These also should be UL listed, as we'll find out in here, or if not UL, at least some third agency listed for the temperature ranges we're going to cover.
Okay, now Larry, let me ask you a question. Is there certain power issues that are SCADA specific?
Well, the power issues that we have are really generic to all areas. They just affect SCADA more than others. In a typical PC that you'd have, like on your desk, or in an extreme, a laptop PC, they have a switching power supply and large capacitance. In addition, the laptop will have batteries. So they can last the laptop through many cycles. The regular desktop through, because it's not heavily loaded, and most of the time, can last for several cycles. But we get into microprocessor-based automated systems where the power is fairly close to the capacity of the power supply for reasons of both cost, efficiency, and loading. You'll find that there are a number of power supply quality issues that will cause us to have low battery life, low component life, cause memory corruptions, measurement inaccuracies, systems halts, shutdowns, and of course our infamous reboots.
Okay, so then Mike, could you give us some examples where automated systems may be in environments that are too harsh for a typical UPS?
Yes. Typical application, oil and gas exploration. SCADA is used exclusively on gas and oil pipelines. It's used for monitoring and management of the pipeline. And these pipelines are in, of course, all types of environments, everything from the North Slope in Alaska down to the deserts of Texas. The SCADA systems provide critical monitoring on these pipelines. In the case of, it's an issue of monitoring the flow, the rate, and also safety issues. And it's extremely important that the SCADA system be up 100% of the time.
Now, Mike, you mentioned extreme temperatures in your slide. Can you define that for us?
Sure. Anything from, the North Slope of Alaska, which is far below minus 40 C, and to the deserts of Texas, which, of course, is upwards of 55 C, 50 to 55 C.
All right, Larry, do you have some examples of some of the types of power problems you may run into?
Right. These are several of these are defined in IEEE 1159, but let's look at some of the more common ones. The first one we'll look at is shown on your slide is SAG, also known as a dip in the other parts of the world. It is a reduction in the RMS voltage or current at the power frequency for a duration of anywhere from a half a cycle to a few seconds. A swell is the opposite condition. It's an increase in RMS voltage at the power frequency from half a cycle to 1 minute. These are generally up to 10%. And under voltage would be a sustained low voltage, a sustained sag, greater than 1 minute. It's often called a brownout. A complete outage, where you lose power completely, can be from a period of time, from several cycles to however long it takes them to restore power, or you get your diesel back up running. That's known as an outage. More important to many of us is the impulse or transients, if you will, sometimes called surges, and they come in different forms. These are generally a subcycle disturbance, usually a sharp, brief discontinuity of the waveform of either polarity, and it may be additive or subtractive on the nominal waveform. We saw several of them in there. Sometimes these pulses will actually be ringing signals, a damped wave riding on one of the wave shapes, and they, of course, will cause numerous problems. A notch is a switching or other disturbance off your normal power voltage. It lasts less than half a cycle, but the polarity initially is always opposite of the polarity of the normal waveform. And then we have our infamous noise riding on the signals, which are either capacitively or magnetically coupled into our circuitry, becoming conducted noise. We have harmonic distortions, not shown on this slide as such, but generally they will distort the wave shape, which causes heating in many of your inductors, and if it's of the triplen type, will cause heating in your neutral. Those are just a few of the power types that have to be addressed by UPS.
Then, Larry, does your SCADA system need an industrial UPS, or does any UPS work?
No. SCADA is going to have one designed at least to industrial standards, mainly because, as we'll go through the operation of UPSs in the next section, that the typical switching, the offline, if you will, UPS, you might as well just buy a surge protector. They offer it and the interactive, which offers some voltage protection, but they really don't protect you against the unregulated or dirty AC power. Only some transients and AC power loss. So as I said, the surge suppressor work as well. An online UPS acts as a firewall because it continuously regenerates pure sine wave power, and hence does away with harmonics and does away with most of the problems. Your SCADA applications not only demand an online UPS, they demand it not only work in normal, what you would call office conditions, but work in environmental conditions that are awfully extreme. As Mike said in the last time he was talking, that you can go from minus 55 Fahrenheit up in the North Slope on a daily basis to above 105 degrees Fahrenheit in cabinet temperature on a daily basis in there. So it depends on what your environment is. It depends on what your equipment is. It depends on your application. But yes, you need an industrial UPS.
Okay, then Larry, there's a couple of key points then I'd like for you to review before we move out of this section. Then could you do that?
Yes, sir, I can. Number one, I hope we've established that a UPS is going to be required to protect against power quality problems, called anomalies, and power outages. Almost all UPSs sold, even in industrial channels, are not UL listed or third-party agency listed to operate outside of the really narrow, from 0 to 40 degrees C, that you find in office settings. Now, the design of the UPS is critical. I've already mentioned two that I would not suggest using: the offline and the adaptive type. We generally want a UPS that is a true online sine wave protector.
Okay, so that takes care of our first session. If there are any questions anybody would like to post on the chat, we could go ahead and answer those now. Or in just a second, we'll move on to the second section. I'm going to ask Mike a question, though. Mike, it came in through the chat thing. Could you further define that extreme temperature? There was some confusion about the ranges.
Sure. Well, if it's an outdoor environment, obviously the temperatures can range from minus 40 below F all the way up to 122, 125 in the deserts. But in cabinet applications or in some industrial applications, the temperature at the
Hello? Hello?
I think Mike may have dropped out.
All right, you want me to go ahead with were there any questions that I can answer? He was talking about the temperature ranges that ran from, minus 55 Fahrenheit to, in colder climates, to well above 105 to 110 degrees air temperatures in the hydroclimates. Do we have any questions from the participants about the need for a UPS in SCADA type installations? Well, Michaela, would you like me to control the slides and move on, or you want to wait until they come back on?
Yeah, I can go ahead and let you continue. Let me find you here real quick.
All right, the next section we're going to talk about is the UPS itself. And we'll talk about the roles of the UPS topologies, battery concerns, and environmental concerns. As I said before, when we were talking about are you back there, Rick? As we said before, the main objective of any UPS is to protect your critical electronics from power quality problems, from power outages. And a true UPS will regulate and condition the AC power in addition to providing your transient and surge protection. It provides power when your utility source fails and acts as a bridge as such until you can get your auxiliary or alternative power sources running. Smart UPSs, and that's what most of them are becoming these days because we put microprocessors into everything, are not only capable of managing their charging and managing their loads, but they can communicate their status to a connected system or to a management system. And we can go all the way from simple contact type signaling all the way up through a Modbus to many more sophisticated simple network management protocol, HTTP-based monitoring and control options. So you have to look at what those features are needed. They are available. Now, an offline UPS, the so-called switched UPS, is the lowest cost, and it is probably quite good for a home PC when all you need is power to cause you to do an orderly shutdown. It only offers protections from some surges, not all transients, just some surges, and from blackouts. Brownouts, it protects about for a while, but a brownout, you'll keep switching in and out of the inverter, and you'll be lowering the battery charge, so when you have a blackout, you do not have the capacity you think you have. You'll notice, you look at the top of the slide, in normal operation, you come in from the AC mains all the way to the AC out. You're just operating on the power. Now, when you have a power outage, look at the lower diagram. Then we switch over to the battery-operated inverter. Of course, the charger is not charging now because it's not there. But the battery is operating the inverter, and you're getting AC out. And these run all the way from square wave to sine wave. Again, it only protects against utility blackouts and limited voltage and transient protections. And you get about as much protection with a surge strip. A line interactive UPS is good for servers. It actually has taps on the AC in transformer, and it automatically, or smartly if you will, adjusts these taps to maintain the input voltage within a fair range. It generally can operate plus or minus about 10% of the nominal range and hold the AC power in there. But again, when you lose power entirely, it switches into its offline or under voltage condition in which the inverter works. And it offers itself no protection other than blackouts and limited transit protection. Now, we had a question, and here's an answer to the question. What is an online UPS? Well, they're called dual conversion because they actually do two conversions, called an online UPS. And if you look at the diagram, you'll notice it looks a great deal like the offline when it's in the power mode. That is true because the inverter is 24/7. You are running your loads completely off of the inverter, which in turn is being supplied by the battery. The charger operates or charges the battery when the AC line is on. You never know. This is much like a laptop computer. You never know if the power is plugged in or plugged out because the inverter is supplying the power at all times. Now, this does require a higher initial cost because the components have to be rated to operate 24/7, and they have to be, rated at the temperature range you're going to operate at, along with the batteries. But that is what is meant by an online UPS. And I should add that the inverter should be of the sine wave type. If you use square waves, it'll heat different parts of your inductive loads and may cause other problems with noise and switching. However, the true sine wave inverter, which most of them are these days, will give you the same power you could get out of a alternator if you were right at the power plant.
Okay, Larry, before we go forward, Mike, is there anything you'd like to add about online UPS?
Yeah. The main thing to remember with the offline and the line interactive is that the power goes straight through. The only, and Larry touched upon this, the only surge protection is a metal oxide varistor, which is the same device in the plug strip. The online UPS, it converts the incoming AC to DC, which removes pretty much most of the power pollution problems. Frequency problems go away. The surge and transients are eliminated. Sags and swells go away. Notches, harmonics, and go away because that DC has been regulated and fed into a PWM inverter that provides not just AC power, but tightly regulated AC power. Typically, the specification on the output of an online UPS is plus or minus 2 or plus or minus 3%. And that's irrespective of the line voltage from battery mode on up to the upper AC operating voltage of the UPS.
All right, so Mike, are there special type batteries, or how do we go about looking at batteries for these UPSs? Larry, can you go ahead and switch the slide, please?
What was that, Rick? I didn't hear you. They were having some audio problems.
We lost our ability to switch the slide.
Oh, okay. I think I can give that back to you, by the way. I'll have to just figure out where it is, because they gave it to me, and
we have it.
Reclaim the host role. Go under participant and reclaim the host role. You got it?
Yeah. We got it. Okay. In UPSs under 15 kVA, the battery that's used more than anything else is called a valve-regulated sealed lead-acid battery, or VRLA. It's the heart of the UPS. Lead-acid technology is used as opposed to the new lithium technologies that are out there and other battery technologies right now, primarily because of cost. And also it has a reasonable power density. However, the lead-acid battery has, as with most batteries, has a couple of Achilles heels, and one is overcycling. In the case of the line interactive and offline battery, every time the utility line or the AC line goes out of regulation, the UPS has to go to battery. So with an offline and a line interactive, you end up with a lot of cycling on the battery. In a typical VRLA battery, the cycle life may be 1,000 to 3,000 cycles. With an online UPS, the battery is mainly used in float mode, and you don't have a cycling problem. But you do have, with all the UPSs, extreme temperatures. You know, high temperature is the great destroyer of batteries. Typically, the other issue is storage without being charged. Sorry about that. Another issue is battery. The battery replacement cost is a substantial part of the UPS. So you want to look for batteries. Not all batteries are alike. You want to look for the rated service life of the battery. A battery with a longer rated service life is going to give you a lower cost of ownership of the UPS.
Mike, are all batteries the same though for these UPSs?
You know, all batteries aren't the same. Even between what's called standard PLA batteries. High temperature UPS requires a battery that's rated for the higher temperatures especially. Lower temperatures don't affect the life of a lead-acid battery. In fact, they can improve the life of the lead-acid battery, but high temperatures can destroy the battery very quickly. In fact, battery manufacturers typically rate their battery life at 25 C or 77 degrees F. When you increase that above 77 F, the battery life will be reduced by 50% for every 15 degrees F increase in temperature.
Well, could you show us what a 5-year battery typically looks like?
Sure. This is a manufacturer's data sheet portion for a 5-year rated battery. If you look at 25C, there is a 5-year life. But when you go to 50C, you're looking at about a 9-month life. There are new technology VRLA batteries that are a bit different. We can go into that. You can see here that at 25C, they have a 12-year life, and at 50C, they have a 4-year life. So what's the difference? The new technology batteries have higher pressure vents. One of the major problems with valve-regulated sealed lead-acid batteries is that at higher temperatures, hydrogen is lost through the vents. And if they're low-pressure vents that's used in most batteries, the vents are typically rated about 2 to 5 pounds per square inch, hydrogen is lost. When the battery goes through its recombination cycle, it's lost hydrogen, it can't produce as much water, and so the batteries over time dry out. The other difference is plate design. There's a substantial improvement in plate design. The plates are better supported, so the temperatures don't tend to buckle the plates in the batteries. The battery case material is improved. Some plastics can actually fuse hydrogen. The terminal connections and the adhesives that are used to seal the case can improve or degrade the battery life and increase or decrease hydrogen loss. Falcon, we use the new battery technology in our SST series, and also because they perform well at 55C, they make an ideal battery for, a high temperature UPS or a wide temperature range UPS.
What about higher temperatures, Mike?
There are special lead-acid batteries, VRLA batteries out there that have an exceptional operational temperature range from minus 65C to plus 80C. They have a 10-year rated service life at 25C, and in the next slide we'll see that that life is not quite as high at 55 as the previous battery. They use, again, higher pressure vents to prevent the hydrogen loss. They're a different design. They're cylindrical wound plates, and they use 99% pure lead, which reduces some of the chemical-related destructive factors in the battery. They're housed in a metal case, so the pressures in the battery can get quite high, and there's less hydrogen effusion. One of the downsides to the battery is that they have a much higher cost. At 65C, next slide, you'll see that they have about a 5-month service life. But again, if it's used in an outdoor application, that temperature is going to be cycling back and forth. But if it's used in an industrial application where it's a fixed 65C, it's about the only battery that's going to survive in that environment. And we can see here the battery manufacturer's float life expectancy on that battery is at 25C it's 10 years, at 65C it's a few months.
So Larry, would you like to summarize for us?
Well, certainly. We've looked here at the roles of UPS and the very important roles of UPS plays in our different applications. We looked at some UPS topologies, and we defined the difference between offline and online UPSs. We looked at a number of battery concerns and found that those battery concerns are related to the environmental concerns that we run our equipment in, and that there are batteries that are of extended temperature range, and there are some trade-offs, one of which will be cost.
All right, so before we go forward, if there are any questions, I'm going to go read those in just a second. We are getting a lot of questions if there's some issue with the audio, which if you're having audio issues, I guess you can't hear this, but we will be posting all of this by audio at the end, and we will be able to talk to any of you folks afterwards if you've had problems getting on, which we'll address at the end of the presentation. Mike, could you go through a little bit for us the selection of an extreme temperature UPS?
Yes. We need to, what is it we're going to look for when we select the UPS to operate at, well, not necessarily extreme temperatures, but in our SCADA applications, which are, when I refer to extreme temperatures, I'm talking about anything other than 0 to 40 degrees C. When you do outside those ranges, as you will if you're outside almost anywhere in the world, we'll need to have a selection guide. So, since we don't have a temperature-controlled environment, you need to look for extended operating and storage temperature, both the batteries and the UPS operating ranges. You want the longest possible battery life for runtime capacity to give users time for the alternative or generator to come on or for orderly shutdowns. You should always design the 25% overcapacity in mind, because at the temperature you're going to be operating at, or the temperature extremes you'll operate at, you should design it in. That means if you're going to be below 27 C, you have to add capacity because the battery chemistry will cause less available current. However, they will last longer. Of course, we've already discussed, and we'll continue to discuss the fact that if you are above this, then you're going to have less life. But in any case, you need to make sure that you have 25% more capacity than you think you're going to require. And some UPS vendors offer options that may be very necessary in your environment, such as conformal coating, which takes away moisture and fungus from affecting the printed circuit components. They also have different hardware options. They also sell the UPS with enclosure, packages, and they have extended battery options such as battery packs and so forth. And above all, you should ensure that there's a safety agency rating for the temperature ranges you are operating over in order to satisfy your due diligence and underwriting concerns.
Mike, before we go forward, we have a question that came in that with these long runtime batteries and extreme temperature UPSs, is there any issue with having generators? How do they react?
With the online UPS, generator is not an issue. With some of the offline and line interactives, because they're sensing the line to do the tap switching in the case of the line interactive, or in the case of the offline, because there's still voltage regulation, they have to transfer the battery at such a high voltage, AC voltage. Switching to generator can cause them to tend to hunt and seek, go between battery and utility mode, or stay on battery mode. With the online UPS, because it's a seamless transfer, number one, to battery, the battery just takes over as supplying as the energy source, and you have such a wide input range, and frequency is not an issue, because you're regenerating the sine wave. Generators are typically not a problem.
Second question I have, Mike, it has to do with enclosures. The question said, are NEMA 3X enclosures or 3R okay? Or if I had a 4X application, what would the effect be?
Well, with the NEMA 3X or 3R, when you get to 3X, that would imply that you have not only an outdoor environment, but an environment that may have some corrosive chemicals or that can cause corrosion in the electronics of anything, UPS or however, whatever. Conformal coating can only go so far. And in that type of an environment where there's corrosive gases or conductive powders or whatever, a NEMA 4X is a better way to go. However, a NEMA 4X is a sealed enclosure. And there's two issues there with the UPS. The NEMA 4X has to be designed with a hydrogen vent. It's a membrane that allows the hydrogen from the batteries that's produced by the batteries to escape out of the enclosure. And the second consideration is the NEMA enclosure is sealed. And with the UPS, it's going to be generating heat due to efficiency losses. And you have to deal with that heat either with air conditioning or a large enough enclosure that the heat can be dissipated through the enclosure walls.
All right, so Mike, there's some questions coming in on special high temperature batteries. I think you have a chart coming up. Could you go through that next for us?
Change the slides, please.
Okay. Well, this Falcon, we offer two UPSs, two families of UPSs. So we offer an SSD series that has a new technology battery on a 1 to 3 kVA range. The UPS has a UL listed temperature rating of minus 20 C to plus 55 C. Has a 12-year rated life on the batteries, and at 50 C, you'll get typically a 4-year service life on the batteries. And for the very high and extreme temperatures, we offer our SST RP series, which is a 1 to 3 kVA. It's rated minus 30 to plus 65, and it's a 10-year rated life. Of course, we're using the very extreme temperature batteries. So, but they are batteries that will survive where no other batteries will survive, and the UPS is designed to survive those temperatures also.
Can you take us to some examples of these temperatures and semiconductors and what kind of...
Oops. The UPS has to be designed to stand these temperatures also. And, one of the most sensitive components, or the most sensitive components in the UPS, are the semiconductors, the ICs, the microprocessors. And the IC manufacturers offer differing temperature range or temperature grades for the semiconductors. And in the standard commercial UPS, the upper limit on those devices is typically 104 F. Let's see, that's whereas in a extended temperature or wide temperature UPS, we would use military grade, which would and the device is rated at 257 F or 125 C. In fact, this chart's a little incorrect. Some of the ICs that we use are rated to 155 C. Where that comes in, online UPSs generate heat through efficiency losses. And inside the case of the UPS, the temperatures can get elevated. And if you were to have let's assume the UL tested product for operation in a normal 40 C environment, and the internal semiconductors were operating at 60 C. The rise in the ambient to 65 C could cause them to be subjected to temperatures exceeding their rating. Basically, you have to deal with that temperature rise inside the UPS that can be 10 to 20 degrees C, and still have the rating to, in the case of our SSD-RP, up to 65 C.
So why is the UL important, Mike?
Oh, a lot of UPSs are being used out there really out of their UL rating category. The manufacturer typically will submit a UPS model or family to UL engineering for evaluation. And the manufacturer specifies the temperature range that the UPS will be evaluated. And with most manufacturers, that's 0 to 40 C. When that UPS receives UL listing for use, that listing is for use in that environment. So it's listed for use in the 0 to 40 C environment. When it's used outside that environment, the UL really is no longer valid. yes, you still have the assurance that the product may be safe up to 40C, but beyond that, the product may not be. The plastics may not be rated for it. The UPS itself may suffer catastrophic failure modes that UL did not observe during their testing 0 to 40C. And so it exposes the end user to some product liability exposure. If the UPS was used in a refinery and it was used outside its temperature rating, and there was a occurrence that caused damage in the refinery, the owners of the refinery could be liable, and their insurance is not underwritten in that case. The insurance company really doesn't have a leg to stand on. So you really always want to verify that, what the UL specified temperature range of the UPS is. And that's typically stated on the data sheets, but not always. There are some UPS manufacturers out there that don't even get safety approvals at all on their products. So you really want to look at that. You can always go to UL. You can look up the manufacturer's name online. You can look up the UPS model number, and you can see what the ratings are.
Okay, Larry, could you go through a little bit about selection of a wide temperature UPS?
Well, yes, a wide temperature range UPS is designed, tested, and approved to operate beyond that standard 0 to 40 degrees C operational temperature that most of your off-the-shelf UPSs have available. They're designed this way because, first of all, the efficiencies are designed in them to reduce internal heat production. They use the higher grade components Mike spoke of in the critical circuitry, so heat does not affect these components. They certainly have different and more efficient cooling methods. They use much higher rated temperature plastics in the construction, and everything that's in there, if it's done correctly and designed correctly, is rated for operation in the extended temperature range. This makes the overall UPS reliability that much better. And remember, reliability has to be designed in. It can't be added on.
All right, so what should I look for if I'm going to look for a wide temperature UPS?
Well, what you would normally do is you would run, first of all, you have to find out where it is you're trying to operate it in. So you would do an on-site temperature audit and get your maximum, your minimums, and of course you can research that data from that it's recorded in any number of places, but you want to make sure that you're going to account for the highest ambient temperature that's going to be encountered and add some to that. If you do get a UPS for these, make sure it is safety agency listed over this required operational temperature. Make sure that the batteries that are in it are rated for operation in these temperatures. And make sure if you have any kind of critical monitoring, if you have any kind of, and this I assume is why anyone would employ a UPS to start with, that you use an online UPS rather than an offline or interactive type UPS. Do remember, though, that when you go into colder climates, you're going to have to add battery life, or battery capacity, not life. Life is extended, but battery capacity, because the chemistry in the batteries slows down, and you'll have to have more batteries for a given capability.
Okay, Larry, before we go forward, my question that came in is, explain to us the issue around why the battery and the UPS both have to be rated for the temperatures that you're talking about.
Okay, first of all, when safety agency evaluates the UPS, it's evaluated with the battery. In the case of standard VRLA battery or the new technology, the plastics that's used in the battery are only rated up to 55C, whereas the metal case batteries, they're rated up to 65C. That's one issue. The other issue is, the battery life. If you use a standard 5-year VRLA battery and try and use it at 65C, the life isn't going to the life is going to be in a matter of days. The battery will become defective. There's also a safety issue there. Using batteries outside the temperature range can bring up a whole myriad of safety issues.
Okay, thank you, Mike. Larry, you want to go ahead and tell us, I think there's some further things that we should be looking for?
Well, would you repeat that, Rick?
Yeah, there's a couple other things that you should be looking for with that UPS.
Well, the UPS, well, first of all, like I said, the safety listing is one of the most important. You need it over the area. Again, you need to make sure that that there is a additional, most manufacturers, and Falcon is one of them, will offer battery packs to extend, the operating time, uptime of the UPS. And of course, those will have to be rated for the temperature you're going to operate in also. I would suppose that, and again, ensure that it is a sine wave online UPS.
Also, we get into this option of conformal coding.
Right.
One of the cases that we have is a customer in New York, is the New York subway system, and they have a steel dust problem down in the subways. We apply conformal coating on those boards to protect the electronic circuitry on the boards from that dust settling on the boards. That conformal option it can be really important in these industrial environments. A lot of UPS companies, they don't offer that.
Okay, Larry, can you review in Section 3 key points for us?
Sure. We had a number of considerations in the selection of UPS. One of those considerations was safety agency listing. One of the considerations was the environment it operated in. We had to consider both those things, and then we had to look at the areas that we actually install these in. And we had such a wide range of applications that SCADA itself, or measurement and observations, or testing, and so forth are done, that you can just about look anywhere on the world and find a place where we have some sort of measuring equipment. And of course, it will have to have a UPS. So there's a wide range of applications.
All right, well, thank you, Larry. Now, I'll check if you could post questions to us right now for any of the 3 sessions. We can go back and review those. I'd like to take a minute and let those questions come in.
I guess I could discuss a little bit about the importance of the UPS and SCADA. Let's take numeric control systems where maybe it's a plant that's producing sheet metal fabrication. The SCADA system that's used in that control system has to have an orderly shutdown. Number one, to not waste material, but also there's a big safety issue. And so, a UPS is required. If there's a power outage without a UPS, then there would not be a safe shutdown of the equipment and the resulting injuries.
Mike, we have a question that just came in about, is there sizing help available to determine what size UPS that you need?
Yeah, the best way to deal with UPS yes, the best way to deal with sizing is to keep things in watts. UPS manufacturers, a lot of them rate the outputs for a load with a 0.7 power factor. Well, most people aren't going to know what the power factor of the load is. But if you take the worst case in watts, if your load is 10 amps and 120 volts, that's 1,200 watts. If you take that, you can't get in trouble. So, if you can get the current of the device, and you know what your line voltage is, you multiply the two together, you get the watts, and basically you have determined the worst case scenario for the load on the UPS at a 1.0 power factor. And
And most of the equipment manufacturers have that specification somewhere easily available. Right?
Usually in their data sheets they talk about how many amps of current. Now, in motor loads, motor loads, things like that can be difficult because you have a very, very high start current. Motors, there's an initial magnetizing current for the motor that can be very high. It can be 10 to 20 times over the rated operating current of the motor. So in those cases, it can be very difficult, and you can always call into the UPS manufacturer and get some assistance there. But motor loads are difficult.
The next question that came in, Mike, was on extended runtime. The question said their application is in the outdoor hot environment of like a desert, but they wanted to know if 2 to 3 hours of battery is reasonable with these new type high temperature UPSs.
Absolutely. In fact, we have high capacity, 40 amp hour battery banks that have very high temperature rated batteries. In the case of our 40 amp hour pack, they're rated for 70 C.
Mike, why don't you give them the example of the fast track that's out here in Los Angeles right now?
Yeah, we have, we're powering all of the toll road RFID and camera systems. The RFID systems are used for automatic payment on the toll roads. And UPS is sitting in a NEMA 3R in cabin, and they want 72 hours of backup. So we have 3 large 40 amp hour battery banks inside that enclosure along with our UPS. And in the event of a utility loss, or in the case of Los Angeles, an earthquake, they have 70 hours of backup.
Thank you, Mike. Hey, Larry, do you have any other courses from ISA that you could talk about?
Well, certainly. The class that part of this was based upon is grounding, noise, and power considerations for instruments, equipment, and computers, known as TI-21. Now, all ISA courses are available anytime as on-site training. Many are available on online training, and not all, but they are scheduled at different regional locations. You can find more information on this by going to www.isa.org/training, or you may call a representative at 919-549-8411.
All right, now for further information, for you people that have been, next slide please, Mike. For you people that have been unable to hear us and still can't hear us, this slide is going to address how you can get a hold of Larry, how you can get a hold of Mike. There's going to be a link that goes off that will get your recording and other information. So I know you can't hear us, some of you out there, but if you're reading this now, this is how you can get the audio version of this. Mike, you see any other questions that have popped up?
Well, I think one of the things, Rick, we didn't discuss was the fact that there are availabilities in different enclosures. The UPSs come packaged differently, and you can get an enclosure that's appropriate for your particular location.
Yeah, absolutely. There's UPSs offered in both NEMA 3 and NEMA 4 enclosure types to handle just about any environment that application may have.
So Larry, would you like to summarize anything from the last 3 sessions that you would like to make sure that you'd like to leave a message for these people? What would you like to say?
Well, number one, remember that SCADA stands for Supervisory Control and Data Acquisition, which means that the SCADA unit has its set point adjusted, but the control is at the SCADA unit, and it has to be powered. As Mike said there are many safety issues with not powering, just abruptly removing power from most processes. And not even orderly shutdown sometimes is that it must go on. As an aside, for those of you who think that perhaps it's too big, I would remind you that the entire city of Fairbanks is on a UPS. which is something I didn't know until I did some research. At any rate, I would say to ensure that pricing is not your most important area, but the features are. You need online sine wave UPS rated at the temperature range you're going to use it in. The batteries that go into it have to have that same operating range. That would be what I would take away from this, Rick.
All right, now we just had a question that came in, Mike, concerning communication. How do I talk to my SCADA systems? What options do I have to monitor my network?
Okay. Most UPS companies offer several ways to monitor the UPS. The industry has decided on the first method is SNMP, Simple Network Management Protocol. And the UPS industry has a standard MIB, or Management Information-Based File. And a lot of manufacturers have a second MIB that supports their extensions for the UPS. And those SNMP boards also usually support HTTP, so there's an embedded website inside the UPS. They're all TCP addressable, and I think they use Ethernet communications protocol. And that brings up another issue, is security on these SCADA systems. You always want to make sure that, you're using SNMP version 3 now, which has full encryption and a hashed password. But beyond that, you want to make sure that you can turn off or reassign the address to all of your communication protocol types that SNMP HTTP board supports.
Now, Mike, is there anything else that you would like to leave with everybody? You're the last speaker of the day.
Yeah, it goes back to this issue of what's the cost of not having a UPS. We had a Coca-Cola bottling plant in the southern part of the U.S. that had a SCADA system, and the SCADA system would hiccup and cause the equipment that was filling the bottles, Coke, to go awry and only fill the bottles half full. Well, what I didn't realize when I was talking to them until later is that they didn't stop that assembly line until they had 10,000 bottles filled. And so they ended up having to throw out and destroy 10,000 bottles worth of Coke and grind the bottles up and make new bottles. So it was very expensive for them not to have an online UPS. And when they put online UPSs on their SCADA systems and control systems, they no longer have those problems.
Well, thank you, Mike. Can we go to the final slide, please? We'd like to thank everyone for attending this morning or this afternoon, depending on where you are, to talk about protecting automated systems in harsh environments. We hope the information is useful and helpful. Mike is available. Larry's available. Please email them with any questions that you have. This is our first seminar with ISA. We look forward to doing more in the future. We wish everyone a good day and a great week, and thank you very much.
Bye, Rick. Bye, Mike.
All right.